There is no such thing as an empty universe. Somewhere in the 2 trillion galaxies we can observe, the smallest possible piece of evidence could already be sitting in a dataset, waiting for a human being to notice it. In 1967, a graduate student named Jocelyn Bell Burnell found a signal so regular, so perfectly timed, that the team briefly labeled it LGM-1, short for Little Green Men. It turned out to be a pulsar, a spinning neutron star, not a message. But what's even crazier is that the search for something less explainable has never stopped since. Radio bursts are the first signal on this list. These are intense pulses of radio energy that arrive from deep space, some lasting only a few milliseconds. In that fraction of a second, a single burst can release more energy than our sun produces in an entire year. Most are traced to magnetars, the collapsed cores of massive stars, wrapped in magnetic fields trillions of times stronger than Earth's own. But a small fraction remain unexplained, repeating on odd schedules from sources we cannot pinpoint. No visible star, no obvious explanation, just a flash and then silence. But the next signal on this list does not flash once. It repeats, on purpose, at a rhythm too clean to easily dismiss. Narrowband radio signals are what most people picture when they think about the search for other civilizations. A natural process, a star, a cloud of gas, a spinning neutron star, tends to broadcast across a wide range of frequencies at once. A signal squeezed into a single, narrow frequency is different. It is the kind of transmission engineers build on purpose because it uses less energy and carries a message more efficiently. In 1977, a telescope in Ohio recorded a signal so strong, the astronomer on duty circled it in red pen and wrote one word beside it: "Wow." It lasted 72 seconds and was never detected again. Nobody knows what produced it, and nobody ever will, not with the data available today. But here is the unsettling part. If a distant civilization only transmits occasionally, we might catch a handful of seconds out of centuries of silence and never get a second chance to listen. That idea, a signal we only catch once, leads somewhere stranger. What if the evidence is not a signal at all, but something built? Megastructures are the next entry, and they exist right now only as a hypothesis grounded in real physics. A sufficiently advanced civilization would need more energy than a single planet could ever provide. Take a star, surround it with an enormous shell or swarm of collecting panels, and you get what's called a Dyson structure, a way to capture almost all of a star's output at once. In 2015, astronomers noticed a star, catalogued as KIC 84628052, dimming in irregular, unpredictable patterns, unlike any known planet or dust cloud. The leading explanations today point to natural causes, uneven clouds of orbiting debris. But for a few years, a partial megastructure sat on the list of honest possibilities. That alone tells you how seriously scientists take the idea that a civilization's presence might be visible in the way starlight behaves. Starlight behaving strangely is one thing. Entire chemical signatures are another, and this is where the search moves from listening to sniffing the air of other worlds. Technosignatures are chemical or physical traces that industrial activity leaves behind, the same way pollution and city lights mark human civilization from orbit. On Earth, a telescope far enough away could detect oxygen and methane existing together in our atmosphere, a combination that should not persist without something actively producing it. Apply that same logic outward. If a distant exoplanet showed industrial byproducts in its atmosphere, gases that do not occur together naturally and do not break down quickly, that imbalance itself becomes the signal. No radio dish required, no deliberate message sent, just a fingerprint left in starlight, passing through an atmosphere millions of light years away. And that leaves us with an even harder question. What happens when the evidence is not chemical, but architectural, on a scale we can barely calculate? Structures do not have to orbit a single star to count as evidence. Dyson swarms, scaled upward, become something else entirely, a shell or ring of matter built around an entire galactic core, harvesting energy from millions of stars instead of one. This is not a small leap. It requires moving and reshaping more raw material than exists in every planet of our solar system combined. No confirmed case exists. But astronomers have run surveys specifically looking for galaxies with the telltale infrared glow that waste heat from such a structure would produce, and a small number of unusual candidates remain under study. The next one on this list does not orbit anything at all. It moves. Rogue signals from moving objects are different from anything fixed in the sky. Picture a source of radio emission with no visible star nearby, drifting against the background over months instead of staying still. A wandering source like that could be natural, an unseen collapsed star, or a rogue planet with a strange magnetic field. Or it could be something else. A transmitter untethered from any solar system, crossing the galaxy on its own timeline. We have never confirmed one, but the mathematics of a galaxy 100,000 light-years wide practically guarantees that isolated wanderers exist, seen or unseen. If you have made it this far into the search for what might be out there, drop a like and subscribe, because what comes next does not just imply intelligence. It implies intention aimed directly at us. Directed transmissions are the next entry, and they carry a different kind of weight than a stray broadcast. A signal picked up by accident tells you a civilization exists. A signal aimed precisely at our solar system tells you it noticed us first. In 1974, scientists transmitted their own directed signal toward a distant star cluster, a deliberate introduction meant to travel for tens of thousands of years before arriving. If any civilization out there has done the same toward Earth, calculating our exact position decades or centuries in advance, that transmission is already crossing space right now, arriving on a timeline we cannot control and did not choose. No conversation, no back and forth, just a single message, sent once, arriving whenever it arrives. But a directed signal at least tells you where to look. The next kind of evidence offers no direction at all. Interstellar objects are physical, not electromagnetic, and that makes them harder to dismiss and harder to explain. In 2017, astronomers tracked the first confirmed object to pass through our solar system after originating from outside it entirely, tumbling end over end, moving too fast to have formed anywhere near our sun. Its shape and behavior did not match a typical comet or asteroid cleanly, and it accelerated slightly as it left, a push that standard outgassing from ice could only partly account for. The leading explanation remains a natural, if unusual, icy body. But the case became a serious lesson. Objects from other stars already pass through our neighborhood, and the next one might not leave as many open questions as it arrived with. An object passing through raises an obvious follow-up. What if something is not passing through, but has been sitting here the whole time? Artifact hypotheticals sit in this territory. The idea that if a probe or structure from another civilization ever reached our solar system, it could remain dormant in the vast, mostly unexplored space between planets for longer than human civilization has existed. This is not a claim that one has been found. It is a statement about how much of our own solar system remains uncharted, how many small bodies in distant orbits have never been closely imaged. Absence of evidence in a solar system this large is not the same as evidence of absence. That uncomfortable math scales up dramatically with the next signal because it does not come from a planet, a star, or even a single galaxy. It comes from the shape of everything. Cosmic scale patterns are the most abstract entry on this list, and also the most debated. Some researchers have looked at the large-scale structure of the universe itself, the way galaxies cluster into filaments and voids, and asked whether any pattern in that structure could theoretically encode information rather than emerge purely from gravity and cosmic expansion. The overwhelming scientific consensus is that these patterns are the natural fingerprint of physics, operating over billions of years, nothing more. But the question itself reveals how far the search has been pushed. From a single radio dish listening to one star, to scientists asking whether meaning could theoretically be written into the architecture of the cosmos itself. And that brings this list to its final entry, the one every other signal has been building toward. The Fermi paradox is not a signal at all. It is a silence, and it might be the loudest piece of evidence on this entire list. Named after physicist Enrico Fermi, it asks a simple question with an unsettling weight behind it. Given the age of the universe, the number of stars, and the number of potentially habitable planets we now know exist, where is everyone? Our galaxy alone contains an estimated 100 billion stars. Even a civilization expanding slowly at a small fraction of the speed of light could theoretically spread across a galaxy this size in a span of time that is short compared to the galaxy's total age. And yet, as far as we have confirmed, the sky stays quiet. That silence has generated dozens of serious explanations, from civilizations being extraordinarily rare, to intelligent life reliably encountering some kind of barrier before it can expand very far, to the simple possibility that we have not looked long enough or in the right way yet. No signal has closed this question. No silence has closed it either. Every entry on this list, the bursts, the narrow signals, the dimming stars, the wandering sources, the object that tumbled through our solar system uninvited, exists inside that same open question. None of them prove anything on their own. Together they are the reason the search has not stopped, and will not stop, as long as there are telescopes pointed upward and people willing to listen. If this kind of search into what might be out there keeps you looking up at night, subscribe and stay close, because the universe is not finished sending us things to explain.